Let's go through the downer problem with all the problems worked out. This is found on page 108. So the questions of interest for the example might include, was the chance of survival related to a person's age? If so, were older persons more or less likely to survive? And then how much more or less likely? So again, the notation is that we have a predictor variable denoted by x. That's a quantitative variable. The response variable just has two values, 1 for success and 0 for failure. And 1 will be survival and a success in this case. It's not really, descriptive statistics is not really so easy to go through because of the quantitative response variable. Generally, we have a blinding set of two horizontal bands. Clearly, a different mindset is needed. So the strategy is we're going to use something like logistic curve and family of functions, presumably, might be new to you, might see it in calculus too. And so we switch our emphasis from the probability of success to the odds ratio. So rather than saying I have an 80% chance of success, I could do my odds ratio of a probability of success, 0.8, divided by the probability of failure, 0.2, and my odds ratio would be 4. Of course, this is merely the probability of success divided by the probability of failure. And what we can do then is take the natural log of that. So we have what's called the logit function. And now we're ready to set up the expression for the logistic equation. So the logistic model is the logit of x is equal to beta naught plus beta 1 x. And that's the natural log of the probability of x over the probability of 1 minus p of x. And so we go ahead and solve this expression, and we get, as we've shown before, the probability is e to the beta naught plus beta 1x, and the denominator 1 plus e to the beta naught plus beta 1x. And then we talk about the role of beta naught, and we can see that as beta naught goes up and down, it changes where we cross the x-axis. It also changes here at the 0.5. It kind of like moves it horizontally across left and right. So the 0.5 result really makes a big difference. And the beta 1 then kind of tells you how steep you go up. If beta 1 is negative, you're decreasing. So the successes are over here and the failures are down here. If it's positive, then the successes are on the right and the failures on the left. Beta 1 does not by itself affect the horizontal location. And so we want to know where the break-even point. The break-even point would be where it'd be 50-50, so the probability of 1/2, and so the odds ratio would be 1 over 1. And we could solve for that, and we turn out to be that x is equal to minus beta naught over beta 1. It's undefined when beta 1 is 0 because that's corresponding to logistic curves that are flat. And so for fixed beta 1, that beta naught governs the horizontal position, just as our previous graphs indicated. In the direction of steepness, we went through this problem again. We found out that beta 1 divided by 4 is the derivative, and that's kind of the steepness of the curve. And now we've finished our time with decent understanding of the family of logistic. We now be able to tackle some things. So again, what we do is we do the maximum likelihood estimator. Again, we'd like to use multiple variable and numerical analysis, but we can't. We find out that the logit function of 1.819 is equal to minus 0.0065x. And just a reminder what we mean by the logit function. On Minitab itself, this is it right here. Oops, that's not, that's for females. The logit function here is that y prime. And then the probability of survival is going to be the exponential of y prime over 1 plus x prime prime. So the logit function here is this linear expression right there. And then we could solve for it and plug it in. Here we put more data points in. You could kind of see that at about age 31, that's when your chances of survival are less than 50%. And as you age, you have a lower probability of success. And so just like we did it before, is the predictor variable related to the success probability? No, 0 adds no, it doesn't add anything to the model, or beta 1 is not 0. We could write a two-tailed hypothesis or a one-tailed or whatever. So we test that, and this is the exact counterpart of t-test, and what we showed is that the t-test was exactly negative 2.06. See right here, the negative 2.06 there. and our two-tailed is p-value, then at the level of 0.05, conclude the data give us significant evidence that the probability of survival for members is related to age. And it does appear that if you look at the data, the older members were less likely to survive. So how is the predictor variable related to the success probability? So in the context of logistic regression model, basically you need to generate an appropriate confidence interval. What Minitabs report is a 95% two-sided confidence interval for the odds ratio. So here's the odds ratio, and this is the 95% confidence interval. But the quantity being estimated is the ratio of the odds ratio of any one year divided by the odds ratio of the preceding year. For example, e to the beta naught plus beta 1x, e to the beta naught plus beta 1, x minus 1. So that's the previous year. You divide, you get e to the beta 1. So the odds ratio any one year is between 88% and 100%. So let's say that you are at age 20. 88% of 20 would be about 17.6. Or your odds ratio would go down by maybe 12%, 0% up to 12%. Okay. And so that's some of the ideas you can do with logistic regression. Maybe we'll give you some more examples to really see how of a wonderful tool this may be.